Ladies and gentlemen, welcome to the 8th public lecture organized by the Civil Engineering Sectional Committee of IESL. Today the topic is going to be very interesting. As you know, this is the first ever tunnel done completely by Sri Lankans. Construction of Kotagala road tunnel by underpassing the live railway line. The speaker today is Dr. Samaradivakara. Dr. Samaradivakara graduated from University of Mortua in 1978. He obtained his BSc Engineering in Mining and Mineral Engineering, then Master of Engineering in Geotechnical Engineering from the same university in 2002, then MPhil again in Rock Mechanics, University of Mortua in 2006, and PhD in Mineral Engineering from University of Queensland, Brisbane. That is his academic qualifications. Then he, in the industry, from 1998, he joined as Geotechnical Engineer in Engineering and Laboratory Services Private Limited. Later he joined University of Mortua as visiting lecturer, then a lecturer at University of Mortua, again full-time lecturer. Then he has worked as a senior project engineer in Newcrest Mining Limited, Australia, and later again, before that of course, he was a senior geotechnical engineer at ELS Construction Private Limited. During that time, this tunnel was constructed. And presently, he is a senior lecturer at University of Mortua. So, I would like to invite Dr. Samaradivakara to make his very interesting presentation.
Thank you very much, Mr. Prabodha. Good evening to all of you and welcome to share our tunneling experience today. First of all, I would like to express my sincere thanks to the staff of the Institution of Engineers Sri Lanka, the IESL, for organizing this seminar and presentation for the benefit of the industry. I also would like to express our sincere thanks to the Road Development Authority and the Director General of Road Development Authority, Engineer Mr. B.V.D.N. Chansiri and Engineer Mr. Mangal Senrat, for granting permission to deliver this presentation. The project is improvement of Hatton Nuwara Eliya Road Project, A7 Road. The client is Road Development Authority Sri Lanka. Consultant is PEC Private Limited, Korea. The main contractor is K&M Enterprises Limited, and the tunnel contractor was ELS Construction Private Limited. In the point of scientific view, this is a direct application of geotechnical, mining and civil engineering knowledge and experience. It was our absolute pleasure to work for and dedicate for this particular project. As Mr. Prabodha explained, this is the Sri Lankans built first road tunnel. I have organized this presentation so that even the non-engineers can understand. I have made it very simple. Here I am going to talk under these subtopics: site layout, background, site layout and the background to the project, subsurface profile, safe work practice, what we did on the site, slope protection work, tunnel design drawings, few of them. Then the tunnel excavation Hatton end, that is hard rock section, and safe tunneling practice, monitoring and quality assurance work, tunnel excavation at Nuwara Eliya end where we had to practice soft ground tunneling techniques. Then the tunnel waterproofing and tunnel concrete lining. This presentation will approximately an hour. This is the former road, it means Hatton Nuwara Eliya road. Under this A7 improvement project, it was proposed to improve this up to 2-lane road. The old tunnel, what I showed here, it is just sufficient for one-way traffic, and it had been a bottleneck in this Colombo Nuwara Eliya road over the years. I checked the history of the tunnel. It's older than more than 100 years, and therefore it had been a mandatory requirement to go for a new tunnel to cater the current traffic demand. The old tunnel is somewhere here. This is the existing railway track, and therefore we had to, it has already been done. I was in Australia when I came. I straight came to this project. Then everything, tunnel axis and all had been finalized. This had been diverted, and this is the new tunnel, which is after construction we measured the length, that is 75.35 meters at the road level. And the most interesting part is this. We had to construct this underpassing the existing railway track, and the railway track also doesn't intersect the tunnel at perpendicularly. It's a curvature. Otherwise, rail to rail, it is just 1.9 meters. Then the length of inference would have to be very less. However, according to this current situation, then length of influence we recognize as 12 meters, which is significant, and we had to take precautionary measures to execute the excavate the tunnel under the railway line carefully. Our tunneling consultant, engineer, well-known engineer, Mr. AKDN Kotagala is with us today. It was our absolute pleasure to share our experience with him, and also we could learn from him. He quite often visited the site. And the subsurface exploration that had been done by ELS, soil investigation team, in 2012 by conducting, that is a direct method of exploration by conducting 5 number of boreholes, which helped to precisely interpret the subsurface. This is a section of the Hatton portal, which is comprised of rock. Actually, this is the rock, and the overburden we can see from the ground level. It is approximately 8 meters. And we had a rock coverage of more than 5 meters. This is a borehole. There had been 5 boreholes conducted, one here, advanced here. The second one, BH2, advanced very closer to the railway track. The other 3 at the Nuwara Eliya. This is a sample from the borehole advanced closer to the railway track. It is actually it should be within the tunnel, because tunnel there's an overburden of 8 meters, then 9 to 14 meters. I wouldn't say this is good rock. You can see it is fractured. However, core recovery was 90 to 100%, and RQD 60 to 100%. It is a bedded formation. Actually, we could see it from these are the pieces of rock came when excavation was done at the Nuwara Eliya end. Access roads. This proves that it is a bedded formation where we found some difficulties in blasting. Especially for the trench excavation, we faced difficulties during blasting because of the bedded formation. Safety first. As engineers, you all agree that we should give priority for safety. We need to look after our workers on site. I practiced this when I was working in Australia. Actually, I had participated hundreds of morning safety meetings. I didn't want to skip that part. We implemented right from the beginning. This is me speaking every day morning. We recruited more than, sometimes we had people, more than 120 people on site. We recruited especially them for this particular project. Actually, 90% of the workers were non-ELS originally. We interviewed and recruited for this particular project. Then we need to control them, guide them, and make them disciplined. Therefore, we needed regular communication, especially safety aspect. This is the biggest project. The ELS spent big money for safety. Therefore, we look after workers, and I'm sure that we maintain world-class safety, health and safety standard. Not only that, we served them very healthy food. We had a well-defined food menu. On Fridays, we served them fried rice with chicken liver. Some one senior engineer came from southern province. He is also from RDA. He really appreciated. I didn't want him to explain. I didn't want to explain everything, but the laminated food menu, he saw that. He said, we said, we have defined this. Then he said, no, this is very important for the productivity. Yes, of course, I tried this. Eventually, the feedback of workers were very good, and we could control them. They behaved very well, and I'm very happy. And also, we did gave some motivation talks, positive thinking, positive words. Sometimes I appreciate it because it is very cold weather in Hatton. People come, they are reluctant to wake up, but I appreciate it like this. It means this is a rare opportunity we got. Colombo people, it's burning hot, and now we are lucky people stay and work in Nuwara Eliya. That's how I encourage them in the mornings. And also, we ask them to work together and have a safe day. That's how we wind up our morning sessions. We appointed a safety officer on weekly basis out of our work team, and his role was to walk around and see how the guys are doing, whether they are not wearing safety items, and any risky thing he points out to the management. That's how we manage the safety. We also established fire safety on site. We installed dry powder fire extinguishers on site as well as at staff accommodation. Not only that, we invited the service provider to come to the site and give on-site training for our workers. By doing this, we achieved zero accidents and zero complaints by the end of the project. That's a term I learned in Australia. When I landed on a remote mine site in Perth, I could see at the airport, target, zero accidents and zero complaints today. It digested in my blood. It means no, zero complaints means lot. Zero accidents we understand. Zero complaints means lot. If I don't get complaints from my directors, my consultants, colleagues, then it is a peaceful day. I can have a good day. We practiced this, we tried this, we understood these are correct. You can see this is a photograph of drilling using YT23 jackhammer with pusher drill. They are wearing all safety devices. That's about safety, and we were lucky actually. There were no any catastrophic accidents, and also just one finger was broken of a worker. We could minimize accident up to that level. Therefore, we are happy. We were capable of celebrating important events enthusiastically because no accidents on site. The access roads, actually we had to stabilize access roads also because we could see this happening in portal. At the beginning we didn't have this much of rock excavation. However, above this soil excavation we could observe it is lateritic soil formation. However, it is not that stable. There was a chance to slip this. Then we consulted CCB and requested to come up with a proposal to stabilize this slope before starting the tunnel. Therefore, we received their proposal to go for soil laying. Then we could stabilize these slopes by soil laying techniques. Soil layers, they are made out of 25mm diameter high-yield steel QT bars. We have to drill holes, 100mm diameter holes, and we need to place the soil nails at the center of the hole. For that we need to get the help of centralizers to keep the holes, to keep the soil nails at the center of the hole. Therefore, we have to weld these centralizers at 1500mm spacing. Eventually, we galvanize the entire setup to prevent from corrosion. Then after installation, we need to do grouting, and this is the wire mesh, that is 100mm by 100mm and of diameter 6mm mild steel wire mesh we use throughout the tunnel and slope protection work by soil nailing techniques. This is a close detail of the soil nail head. This is the soil nail and this is the grouted form, and initially we need to go for 75mm shot grid. Then wire mesh, then we have all other nuts and bolts here, the plates, they all galvanized, we fabricated them. That's how the soil nail is installed. The drilling was done by means of two types of machine. This machine ELS specially, this is SM400. This machine is specially brought for this project. The company has the similar three machines having the same capacity of drilling. This is a collar-mounted machine, and therefore it has a great flexibility to move over the rugged terrains and access and make the holes. Actually, this is a slope which we excavated with the help of enterprises in stepwise. Perhaps the machine, right at the beginning, the machine worked up here. Once we completed that part, we requested them to do the excavation, then we moved down and so on. That's how we managed to do without scaffolding. However, this is the other type of machine that we call hole drilling machine. The company called three this type of machines. This is a very flexible machine. It means the machine itself could be mounted on GI pipes, scaffoldings. It is connected with these hydraulic hoses, and the controlling unit is this, and also the hydraulic unit is far away from here. Therefore, this is airline lubricated. This is very flexible, and at the moment this set of machines we are doing the ELS is doing slope stability work at Nanwal, closer to the railway station. This is a slope protected slope, protected slope at Hatton. You can see the drainage was facilitated by the surface cut-off drain was built up here, and vertical drains were built by means of no-point concretes here. And this is under the quality assurance work. We have to do 5% of pull-out test for all the soil nail wall. This is the slope protection in Nuwara Eliya end slope. It means the portal slope itself we had to protect by means of soil nailing technique. That design we got from RDA. There were minor differences in between the CCP design and this design. However, eventually the length be increased as it is the same formation. Soil nail lengths initially they were 6 meter. However, they were increased up to 10 meter depth. This photograph is from Nuwara Eliya. This is the Nuwara Eliya portal slope face. Actually, the tunnel was supposed to be here. Still, the stabilization work going on. I selected this photograph just to give an impression how we were closer to the train. It's very close. Therefore, once the excavation was earth movements were done, then we need to protect this slope as soon as possible. Therefore, our boys work day and night, double shift, and protect that as soon as they can before the heavy rain falls. By that way, we ensure the safety of the structure. As engineers, we should not restrict the design part. Therefore, I have included a couple of design drawings here. Thanks to RDA, we have mentioned, I have quoted the source of material. This is actually the drainage we revised later. It was confined to one single line of 1200 millimeter diameter, internal diameter precast concrete pipe. Apart from that, you can see a lot of pattern walls in the design, 4 meter deep, 4 meter long diameter pattern walls, then 150 millimeter thick reinforced shotcrete, 50 millimeter thick for convergence and deflection, then 100 millimeter thick permanent concrete lining support. That is the structure, that is the design for the Hatton hard rock section. Then the next one for soft weak rock formation, you can see the number of pattern balls increased. A part of these design drawings, whenever necessary, we have to do a spot bolting to support wherever loose formations. We have to support. We need to install anchor bolts separately. Then when we come to the hard rock section tunneling, we did up to 50.5 meter length starting from Hatton end. Then after, actually we did the advancement from both ends. We started from Hatton end, that is rock tunneling, drilling, charging and blasting. And whereas from Nuwara Eliya end, we had to practice soft ground tunneling techniques using lattice arches. Before starting that one, as per the design, we had to advance 54 millimeter diameter, 12 meter long heavy duty pipes. We call 4 poles. They were perforated, and after installation, drilling and installation, we did pressure grouting. So that you can imagine that when we do pressure grouting, there's just like a blanket is formed above this level, which make stable strata, so that facilitating advancement of the excavation. These are the 4 polings. You can see the actual 4 polings we advanced and grouted. Then after only we started excavation. By that time we have already done slope protection work by soil nailing. Then only we started the excavation for the installation of the lattice arches. This is another drawing of the Hatton portal. The tunnel geometry, which should be interesting to everybody. We need to study the tunnel geometry because as we had to build lattice arches, temporary supports for the soft ground tunneling, and also to build or fabricate formwork for permanent concrete lining. Here these comprise of 3 arches. Here one arch is here, bigger arch, and symmetrical 2 arches here. Center point is here, and it comes up to here, and these are 2 straight parts. That is the geometry of the tunnel. And after completion, we have a working height of at the center 6.5 meter height, whereas the old tunnel had only 4.8 meter height. The working width at the road level, the new tunnel is 7.1 meter, whereas the old tunnel got just 6 meters. And the lengthwise, the new tunnel is 75.35 meters, and the old tunnel 26.7 meters. This is the fabrication of lattice arch. Mr. Bandara did this based on his Samanla power tunnel experience. He pulled out his old notes from Samanla records, and we fabricated this one. We put it here. We maintain 3 joints. Joint 1 at crest here, and J2 and J3. They are at the places which I mentioned, straight parts. The sectional view of it is made out. These were made out of 32 millimeter diameter HYS QT bars, and you can see shear bars in between. That's how we fabricated this. Then, as I explained earlier, we move them in 4 pieces, each lattice arch, and assemble on site. These are the lattice arches, temporary supports for the soft ground tunneling. We did for at the Nuwara Eliya. The fabrication of formwork for permanent concrete lining. We use C channels and HIMs for this fabrication, and also this was fabricated in pieces, and the fabrication we did on ELS Bemulga factory premises, and we moved them in pieces to the site and assembled on site when it was ready for the concrete lining of the tunnel. These were moved by the crane and positioned, and that's how we made the arrangement for concrete lining of the tunnel. The tunnel excavation was the hard rock tunneling in Hatton. We did it in 2 steps. First part, it means starting from the ground level below 4.5 meter height. That part we did first. For that we used YT23 jackhammers with pusher legs. We did horizontally, and charge blast. That was heading operation. Initially that is only for 4.5 meter maximum height. Then after balance 3.5 meter depth, we had to drill vertically downwards, and we did pretty much bench blasting for bottom part. That's how the rock excavation was done. This shows YD23 jackhammer. At the moment the company got 11 machines. This is a pneumatically operated machine, and it's pretty heavy. However, when it is energized with compressed air, the leg itself can raise the machine up. Therefore, even a single person can operate it. But at the beginning, for the drill rod, someone should give a support to position to the correct drill hole location. Once the tuning up is done, even one single person can manage to complete the drilling. So, blast design pattern. The tiny numbers are, I'm sure that they are not clear to you. If you are interested in, after the presentation, I have got the colorful A3 printout with me. We did a trial here on site, and we recruited one blasting engineer, a young mining engineer from Boulder Mines who got a lot of experience. Mr. Champika is in our audience today. Then after we consulted one blasting expert, engineer Mr. P.V. Hemal from University of Morocco, and he supported to finalize this blast design. Here we use immersion explosive, which is becoming more popular, and also we couldn't do blasting carelessly here because we have to do very careful blasting here because of the railway track. If it is so, if it was an isolated location, we could do this blasting when excavation faster. However, here we have to take utmost care and precautions especially because of the railway track. Immersion is good. It means less powerful than dyna, but at the moment dyna also is not recommended for. It's strong strength-wise. The dyna is more powerful than immersion. However, in the point of scientific view, dyna emits more chemical or fumes during the blasting, whereas immersion less emissions, and therefore immersion is becoming popular. We use immersion explosive throughout, and the delay method we use the non-L detonators. This has a great choice of selecting delay numbers compared to electric method. The diameter of the blast holes 36 millimeter, and number of blast holes for one particular blast phase was 196. Number of charging was confined to approximately 144. Now you understand that something left blank or dummy. It means that was around this we call contour. It means that is the controlling line of the tunnel. Here we have to use a strategy. It means we charge only each hole after 3 holes. Right? Each third hole we charge here during the blasting. Then we left two empty holes in between. That is advantageous in 2 ways. Number one, propagation the crack and get the contour along that line, and also to minimize the propagation of blast via the rock mass. That practice we did. Actually, initially we did the cut hole because I showed you SM400 machine. That drilling machine, then we did the longer hole. It means that was advantages in 2 advantages are there. Number one, when we initiate the blast, there should be a space to release the pressure. Then that cut hole we don't charge, therefore that pressure is released into that dummy hole or empty hole here. Then the initiation is here, then it is the rock pressure, the blasting pressure is released into the hole, and so on. That is propagated like that. If you visualize this, it is blasting is another art of science. From here you can see the correct phase here, that these are cut holes, and these numbers related to that design. Right. Here now you can see after drilling they are charging. I'm sure this is the day the DSMB also came to give the measure, get the parameters, blasting parameters, and give the approval. So there is a mandatory requirement, government requirement. We need to get the approval for rock blasting. These are the parameters. It's air blast overpressure. We cannot exceed 120 decibels. we cannot exceed ground vibration 5 millimeters per second. We were within the limits, and Geological Survey and Mines Bureau officers, they cooperated very well, and that's how this is our foreman. He did a great role during this tunneling project jointly with Mr. Champika Karunathila. Further, just to stop fly rod, to ensure no fly rods coming out, we built up a shield out of sheet piles, and it was handled by this Manito crane. We ensured that because there were some houses towards this end, there were houses at the vicinity, and we need to make sure that even a tying rope wouldn't be flown to their houses and damaged. We didn't want complaint, right? We target 0 complaints. As I explained earlier, 0 accidents and 0 complaints we targeted. We always try to minimize those. We had to fabricate a bench for blasting, because on this platform we could accommodate 3 drill machines, then 4 drill machines underneath, and that's how we managed to blast that much of large number of holes, 194 holes per one blast, one phase. People worked day and night. We had accommodated people, and we had organized 2 shifts to work. That's how we managed to do this excavation. And also, as the tunnel was advancing from both ends, we did regular survey checks to ensure that tunnel is heading according to the design, and also following up the center line. Those checks were regularly done, and also survey helped to draw the blast holes, or position the blast holes for the team, and alignment checks. You can see here these wires are coming for 3 machines, and this is the drilling platform to approach higher levels, higher elevations, to drill more holes. Night shift, whether it was cold, rainy, windy, our people went ahead with utmost courage. Night shift absolutely very cold up in Hatton, freezing in the morning, sometimes it is foggy. Even I can remember when I was driving back to accommodation, sometimes vicinity was very poor, like after 9:30, 10. Sometimes I followed the side white line of the road just to locate the road. But people worked very hard during very cold weather and also rainy weather. We had our team were very strong, and they had the enthusiasm to go ahead. This Manito crane that helped a lot. It is a very flexible machine for lifting of people, and also this has the facility we can accommodate 1 jackhammer to drill a hole sitting from this page. That helped throughout the project, and now the company, I think they are considering to buy the second machine. We use these for removal of mud from the blasting. After finishing the heading operation, then our people started benching. That is, as I explained, we drill downward drilling. That is fast and easy. It is the general practice at quarry mining or bench blasting. Again, I am going to explain the precautionary measures that we took under the railway track when we were advancing this 12-meter stretch. The weight of a train engine, it's to keep the traction is the most heaviest part of the train. I spoke to one, I have a schoolmate who is an engine driver. I rang him last evening and I checked the weight again. He said, don't hesitate to mention that the heaviest engine is the 120 ton heavy one. That is the M10 model, but the government has recently purchased from India. Therefore, the load could vary from 60 to 120 tons. It's a risky work. However, as per the instruction given by consultants and our basic rock mechanics knowledge, we took all our precautionary measures to ensure that we drilled one drill hole, blast hole vertically upwards to check the rock thickness always. We had been instructed to make sure that you got 5 meter thick rock layer over it before giving approval for the next blast. By that way, we took, we immediately after blast, during the mucking itself, we did supporting of all loosened rock parts and that of thing. And further, for this particular 12 meter stretch, consultants agreed to give permission to go for shock rigging with a single layer wire mesh. The same wire mesh I mentioned, we use this wire mesh throughout the project. This process, it means we did 50 millimeter thick shotcrete layer first, then we install the wire mesh, or some instances we use, we managed to cut enough metal pieces and install first, then install the net, and simultaneously we did the shotcrete. I mean, first layer 50 millimeter thick, then the wire mesh, then after 75 millimeter thick shotcrete layer. Further, we have to do convergence and deflection monitoring. That was done by means of tape extensometer, which brand new we bought. The company bought this brand new especially for this particular project. This shows how the measurements were taken throughout almost 25 days. But further, these are not significant. It means that the deflection is here 0.25 millimeters. We have installed hooks on the excavated surface at regular interval, starting from Hatton to the Nuwara Eliya, and our laboratory staff, every day morning they measure this and ensure that there are no significant movements in the excavation. This taking of tape extensometer readings. This specimen of anchor pull-out test result. Similar to soil nail anchors, we did a lot of rock anchors. Then we had to do the quality assurance work by conducting pull-out test. It had been designed for 150 kilonewtons. You can see once we release the load, it has turned on up to 0.2 millimeter deflection, which is negligible. Throughout the project, we maintain this quality assurance work with the presence of the consultants. Again, the quality assurance of wet shot reading. Always we casted panels out of the samples we use for, it means wet shot reading. Then we had our own facility to do the coring and testing with the presence of consultants. We did all testing at consultants' laboratory. Then for concreting, we did cube casting followed by testing to achieve the design 30 megapascals within 28 days. Then I would like to explain the tunneling process, software on tunneling. You can see after I explained after flow protection, then after propoolings, doing pressure grouting, then only we started excavation. We had been permitted only to attempt 600 millimeter excavation at a time, and then to install the rig or the lattice arch. We had to do a lot of pattern bolts, grouting, shotcreting, then only you are permitted to advance further. You can see the soil here. It's highly decomposed rock. And another problem at this end was seepage of water. A lot of water was seeping at this end. And once contaminated with water, this soil, it drops like in lumps. When you try to excavate slowly, now they drop. Therefore, workers, we instructed workers to look after them and wearing safety devices, and we had to do it very carefully. After installation of a lattice arch also, then further excavation we did very carefully. You can see here after installation of the first lattice arch, then I put this diagram to remember that we need to do a lot of Hatton bolts, and this is drilling by means of again YT23 jackhammer to install these Hatton bolts. Then we need to do grouting and shotcreting before advancing further. Even though we planned this absolutely for soft ground tunneling, we encountered some rocks on and off. That was another trouble. Means when we tried to cope up with the time schedule, this was another problem because we had to do how to do this blasting. Now we cannot. The rock was not that soft on left hand side. It means the hilly side, that is competent rock, hard rock. We cannot take it simply from the excavator bucket. No, it doesn't work. Then next step is we need to go for control blast. Then it is to be done very carefully, because if the blasting vibrations are significant, then what happens next? This collapse. Collapse means no one can predict the extent. It could come from right from the top. It will be a disaster. Then it is something to be done very carefully and patiently. This shows the after installation of these lattice arches, we have to do shotcreting. Then bottom parts, they have over excavation. This means sometimes excavations we couldn't control to the perfection because it's rock blasting. We need to balance things. We have to balance things, rock blasting, and we need to go for the excavation also. We need to advance forward also. There were some extra excavations here. Then in such instances, we have to put some formwork and fill with either concrete or shotcreting as advised by the consultants. The wet shotcreting in progress. This wet shotcreting pump ELS brought brand new for this particular project. Then I was very lucky to work for this project. A lot of resources. My directors were so helpful at that time. I dedicated upon the site 90% of my time during last 18 months I spent in beautiful Hatton. And whenever we need anything, when we spoke to my directors, engineer Mr. Bandara and Mr. Nuwara Eliya is sitting there. It was very easy to work with them together because they make decisions lightning fast, and it's we also work enthusiastically because of that attitude. That's a typical behavior or the culture of ELS. It was the first job also I did. Still I have got connects with them because they work very fast. When the soil ground condition was not that good, we did the shotcreting for the soil slab as well for the safety. Then only we followed the excavation. The manual crane, we shared both ends because that was the most useful crane on site. Nighttime work. We had diesel powered light generators. Sometimes during the night shift we got more light than daylight. They were that powerful. The entire area was illuminated. I think that is psychologically there's a big advantage for the workers because they feel it like daylight. Honestly speaking, they were very, very powerful, and we got more light than daylight, nighttime, because of our diesel powered light generators. This shows the installation of pattern bolt. It means this person is holding a PVC pipe. It is in-out grouting because when we insert the anchor, it is we always connected the PVC pipe to facilitate in-out grouting. After the installation, then we ensure that the grout is filled from very bottom, very end to the nearest place of the hole. Again, another control blasting at Nuwara Eliya. Then once they finish heading operation there, after installation of lattice arches, they again started drilling downwards and benching operation. The removal of mud. Luckily this time, as is the hill area, it means the railway track is somewhere here. Then you can see we encountered rock. Therefore, we didn't want that straight part of the lattice arches for this section. The rock itself supported the lattice arches. Anyway, they are temporary supports. We have to do waterproofing because to look after for the durability of the permanent concrete lining of 600 mm. Waterproofing, actually we had to bring down the foreigners for this. The company bought all devices necessary for this. This person is using welding equipment. We call it waterproofing membrane welding equipment. It is just like a heater. It emits warm air, and these membranes are weldable. The foreigners, we got a good training for our workers from them, and eventually now look here they work together. Initially we need to install geotextile membrane immediately after the rock. It means there are some discs, PVC discs. They got a gun here. This gun is loaded with special this nail, and they shoot. That's how they fix them to the rock. Or the surface smoothing is mandatory for this work. Otherwise, we have a doubt during the permanent concrete lining, the concrete pressure would deform the membrane. Therefore, smoother surface would be better for installation of waterproofing membranes. You can see the disc, and then after only they together, can you see here, together they install the waterproofing membrane. For this one we couldn't use the Manito crane, even though it is very flexible, because big reels of geotextiles and these waterproofing membranes people had to handle. Therefore we did this sitting on a big scaffolding, but we did it very carefully and safely. You can see a lot of aluminium ladders. Anyone could easily walk up safely. That's how we did this job. This is the waterproof area of the tunnel. On left hand side it is 30 meters, whereas right hand side 51 meters length, depending on the seepage of water. Then at the bottom, what happens is when water seeps, it is absorbed by the geotextile membrane and it seeps through up to the very bottom of the waterproofing membrane. Then here in the end we need to connect this to drainage pipes. Luckily this membrane is weldable to PVC. We could easily weld it perfectly to the PVC. We had two longitudinal pipes and lateral styling pipes at 2 meter interval. That's how the drainage was facilitated. Then we started tunnel permanent concrete lining. It started from Hatton hard rock section and advanced up to the Nuwara Eliya. Meanwhile, the people finished waterproofing work at Nuwara Eliya. This is the trench. It's 1200 millimeter internal diameter trench. It's precast pipe from ELS again. We have to do a box culvert here. People work day and night, and they did a great job. This is bar fixing for concrete lining at Hatton. You can see we brought this and dressed up the Manito again help for this work. Then after we placed the frames and did concrete lining. This image captured from the Nuwara Eliya. We can see how it should be happening. This is captured from Nuwara Eliya, and you can see the concrete lining team advancing from Hatton to Nuwara Eliya. Now here at Hatton, the bar fixing work could be easily supported by rock anchors because it is rock. However, for waterproofing membrane section we couldn't drill further because it is to be watertight. Therefore they were supported to the formwork themselves. This is a big day on site. When we completed the internal concrete lining, people celebrated this. We had some fireworks, drinks on site, and they were singing and dancing. They celebrated because everybody could have the peace of mind after finishing of internal concrete lighting. There's nothing to collapse. We also supported them. We also shared the pressure with them. That's how we kept the motivation to go in. Still, I get some appreciation from the workers, and it has been a memorable day for them. I went to find fireworks, but I couldn't find any. And then eventually, I brought the tiny fireworks, and we had to steal strings here just to guide them. Otherwise, they go here and there. Then I asked the most hardly work people to come forward and please fire this. Then they are capturing photographs of this. It was a pleasure of us. We also joined them and enjoyed this day. Then after we started finishing portals, this is the concrete lining of the portal, and right from the actually the concrete lining we did it in 12-meter segments. From the rail we completed the 12-meter segment and started removal of the formwork. We started finishing work. These people are doing some minor grinding and finishing or smoothing the surface. That work also continued day and night. Then the finishing of the tunnel portals for the durability of them and also the appearance. We brought down a supplier who goes from quarry to quarry and select rock pieces. One side is fairly flat, and he cut into 1 feet. These pieces he brought down, and we fixed. Our people fix them manually. This is the finished tunnel. Then after we had to do lighting. We brought them down again from overseas, LED lighting, a very economical lighting we did with the help of supplier. This is the illuminated tunnel, nighttime view. 7 LED lights are there. Each consume only 94 watts. Actually, eventually, the original design was to illuminate 7 lights daytime and 4 nighttime. However, by doing trials, they realized that 4 is sufficient. This is automated. It means a combination of clock and a sensor. Clock time is from 6 p.m. to 6 a.m., 12 hours. However, if there will be bad light or cloudy weather, then the sensor triggers this and illuminate even daytime. Even though we illuminate 7 together, it doesn't consume 1000 watts. Acknowledgments. I mentioned Director General at the beginning of RDA, Engineer Mr. Senrath and Engineer Mr. Badegama. They quite oftenly visited the site and cooperated very well, and I appreciate, and they were very positively talking and supporting, encouraging us, which is to be commendable. Then our consultant, Mr. Atukor, engineer Mr. Atukorla, he visited quite often from Umayo project site, and he helped us. Then engineer Mr. Hemalal, he was our blasting. He is one of my teachers also long ago, and he very cooperatively helped us to finalize the blast design. Then the PEC Private Limited, engineer Mr. C.D. Kim, he was a team leader from Korea. And engineer Mr. Palitha Ekanayaka, former deputy team leader, he cooperated very well. So very good, positive person, and he gave his fullest support to execute this project to success. K&M Enterprises Limited, Mr. Y.H. Khan, project manager for the big project, A7 Road. He's a good person, and he enthusiastically helped us, cooperated very well. Mr. Shin, Mr. Anushka Vidana, and they are blasting engineer, Mr. Chandana. They all helped us, and that's how we could successfully complete the project. All of you, whenever you drive to Nuwara Eliya via Hatton, you will find this beautiful base, and you will drive through this beautiful tunnel. I'm sure you will enjoy it. Thank you very much for your attention.
Now the floor is open for clarification, questions, suggestions. You can come out to the stage. Okay.
Safety measures taken. I showed you that actually continuous monitoring, quality assurance work, and also the additional precautions we took when we were advancing under the railway track. One single layered wire mesh shock treating. And immediately after each blast, actually our mining engineer, his role was to do 12-hour inspection continuously. Whether there is any weak formation, loose rock fragments, we immediately supported them. We drilled through them and supported to the hard strata, grouted the rock anchors. That's how we supported and ensured it's pretty safe. Further, as I mentioned earlier, we had instructed the blasting foreman to drill a blast hole when they drill, let's say heading operation, when they were drilling forward, we advised them to drill one hole at the center line upwards, 5 meters, to ensure that 5-meter rock thickness is there. Apart from that, we asked to collect all rock cuttings and we logged them. We had a close eye. We kept a close eye what cuttings are coming and which formation is there, because you understand in investigation it is not economical to do a detailed investigation. One borehole costs big money. That's why they have done 5 boreholes according to the budget. Otherwise we are very happy to have boreholes at 1 meter interval. It's not going to happen. But as an alternative method, what we did was we did some continuous monitoring and that type of additional holes, and to see the rock strata, logging, quality assurance work, anchor pull-out tests, then additional precautions that we took under the railway track. Those are and also the convergence and deflection monitoring to ensure that no movements, because visually we cannot see. There could be a movement. If so, they should be measurable. Those safety measures we took. And also I mentioned safety meetings every day morning. We inducted our workers. We discussed any mine accident happened yesterday. We asked why it happened. What are the precautions that you can take to stop happening it again in recurrence. We stopped the recurrence. And that way I was always wearing my safety spectacles. Mr. Mangal Sanrat is witness. Whenever they come to site, they see it. Helmet, boots, gloves. Means we became role models for the workers. Then by that way we encourage them to wear safety devices, and that's how we look after them, and no accidents on site eventually. We are happy and people were happy, and we peacefully distributed, and it's a clean, nice site. Now you can go and have a look. Sorry? Ventilation, actually honestly speaking, we didn't have ventilation problems because it is a short run, 75.35 meters. 2 meters, yeah, still it was manageable. It was manageable. But after the tunnel breakthrough, there wasn't any requirement of ventilation. Yeah, it's a short tunnel, that's the reason. Yeah. No. The formwork, the frame is made, it is C channels and combination of C channels and HIN, but I couldn't explain, sorry about that. The structure is steel, however these yellow pieces, they are Eurofoams. We brought down a full container of Eurofoam plus accessories from Korea. Can you see here? According to that, it means the curvature, how we achieve, if this is the tunnel, we take Eurofoam sheets, they fix like that. Eventually it become a perfect surface. Now its structure is metal, but it is it's a soft form, it means repairable form. Mr. Bandara, can you remember? Like plywood, similar to plywood, but with a coating or something. We can replace that part, but the main structure is steel frame. When I go to site now, I cannot imagine whether we did it or not. That much of work. Now it looks like a piece of cake now, but it was full of mud, coldness, lot of troubles. Any more questions?
I just got a question.
Yes.
It's part of the presentation.
Oh, excellent. Thank you very much.
See that my friends have done this one, and more than anything, that we gained our confidence people. You remember, you are people. So 30-40 years ago, there were people doing tunneling machine. We as people, we lost their staff. But when we lost it, but the opportunity is about. So at last, I'm very, very glad to see, and particularly glad to see my friends are doing it, and congratulations on the great job.
Excellent. Thank you very much.